In section 11.4, we're going to start talking about some of the transformations on the conic sections that we've talked about in sections 11.1 through 11.3. So we're going to learn to write the equations of a translated conic. We're going to graph those translated conics, and we're going to determine the shape of the translated conic. And sometimes we can do that without graphing, and we're going to look at some real-world problems. So for horizontal and vertical shifts, if we have h and k, this is much like the transformations you've seen before, and replacing x with x minus h and y with y minus k is going to give us an absolute value of h. Is going to be the right for positive h and left for negative h. So then the k is going to give us upward for a positive k and downward for a negative k. That's the transformation that's going to happen. And for graphs of second degree equations, we can use this formula here. If we put it in the form ax squared plus bxy plus cy squared, if we put those up front and a, b, and c are not all 0, then we would have a circle if b squared minus 4ac, a circle or an ellipse or a point if b squared minus 4ac is less than 0. We could have a parabola, a line, or two parallel lines if b squared minus 4ac is equal to 0. Or we could have a hyperbola or two intersecting lines if b squared minus 4ac is greater than 0. This expression here is called the discriminant. You can also complete the square and be able to identify, better identify what the conic section is. And we're going to focus primarily on completing the square when we need to. This example, we don't need to complete the square though, so we're going to start with it. In this example, we are asked to identify and sketch the graph of this conic section. We're going to find its center, its major axis, and its minor axis. All right, so with this conic section, you notice that we have this plus 3 and this minus 6 here that we haven't dealt with before. That's going to be our h that we talked about, and this is going to be our k that we've talked about. So what we're going to do to start with is compare this to a parabola with center at the origin. And let's even take that equation a little bit further and rewrite that. Instead of 25 and 9, we're going to write that as 5 squared and 3 squared. So now it's in our form, and we know what we have, since those denominators are different, is an ellipse. Okay, so if we have an ellipse here, then what we would need to find in order to sketch a graph would be its center. And it mentions finding the major axis and the minor axis. So let's say our major axis and our minor. We're going to find our vertices, which are going to be on our major axis. And then the other one, on the other, is going to be the endpoints of the minor. And so if we find all of those things, then we should have enough information to sketch a graph. Okay, so for each one of those, we're going to be finding an x or a y. Sometimes it's the equation, and sometimes it's just a point. So when we have the center, we're going to start with the center at the origin, and we're going from this one here. The major axis, since the 5 squared is larger than the 3 squared, then the major axis is going to be the line y equals 0. So we're going to write the equation there. And the minor axis is going to be the equation x equals 0. And for the vertices again are going to be on our major axis, which is going to be, this time it's going to be our x-axis. And that makes our vertices, if we look at our 5 squared, it's going to be 5 to the left and 5 to the right of the origin. So we've got 5, 0, and negative 5, 0. And then for the endpoints of the minor axis, we're going to have that above and below the origin. And we use the 3 squared, so 3 above and 3 below, so 0, 3, and 0, negative 3. And now from here, what we're going to do is we're going to say, okay, what was our transformation? Our HK was the point, it's going to be that point negative 3, positive 6. So that's going to become our center. So HK is our center now. So what happens in that case is the H is going to move us left 3, and the K is going to move us up 6. All right, so what we're doing from each of these is just a transformation like what we've done in the past. So here we're going to go -3, and on the Y's we're going to go +6. So when we get our new points over here, X, Y, that's going to give us a center, -3, 6. And then for the y equals 0, it's going to become y equals 6. The x equals 0 is going to become x equals -3. The vertice 5, 0 is going to be the point, so I subtract 3 from the 5 and I get 2. I add 6 to the 0 and get 6. And then the -5 is going to become -8. And the 0 is going to become 6. The endpoints here, the 0 on the endpoint 0, 3 is going to become -3. And then the +3, I add 6 to it. And that's going to give me 9. And then I have -3, 3. Okay, so this one here is the transformed. So once I have that, then I can just sketch an ellipse. We know we have an ellipse where the major axis is our x is going to be. So we're going to have something like this. So I would just sketch an ellipse and then start labeling everything. Okay, so what you have is your major axis along here. And we know our major axis is going to be the equation y equals 6. And our minor axis is going to be here. And this is not on a coordinate plane. Of course, if you had a coordinate plane, then you would be plotting points. So our minor axis is going to be x equals -3. And our center, that point is going to be -3, 6. And then our vertices are going to be at 2, 6 and -8, 6. And then we could go ahead and label these two also. That's going to be the point -3, 9, and this is going to be the point -3, 3. Okay, and then we have the sketch. And of course your center, your origin for your graph is going to be down and to the left of that, if you were to have graphed it. And let's go ahead and look at the next example. This time we're going to identify and to sketch the graph of this function here, or this equation. So what you notice here is that you have an x squared and a y squared. So most likely it's either a hyperbola or it's going to be an ellipse. You know, it's one of the two because it has two quadratic terms in it, your x squared and your y squared. All right, so from here we could use that formula that we did back earlier, we looked at to find out what we thought it might be, this formula here. And if we're doing that, we might want to rearrange our equation just a tad bit. And we might want to rewrite it as 9x squared plus, there's no xy term, so I put a 0 there, plus 16y squared. And let's just leave it like that for the moment because that's all we need. So then to find our discriminant, we go 0 squared minus 4 times 9 times 16. And when I do that, I recognize that this is telling me that it's going to be a circle or an ellipse. Now we're going to have to complete the square anyway to figure out exactly which one it is or graph it. So you may or you may not want to do that step. That narrows it down to being a circle or an ellipse. So now let's talk about actually completing the square. And remember, this is sort of an optional step. step here. All right, so we have our equation. What I'm going to do is arrange that equation such that all of our x's are sort of together and our y's are together, and also at the same time, I'm going to move the constant to the other side and set it up to complete the square. So I've got 9x squared, and then I've got a plus 72x, and I'm going to leave a blank because I want to complete the square. Then I've got my y terms, which are 16y squared, plus the 96y. And I'm going to leave a blank, and then I'm going to move that 144 to the other side, and I get that. Okay, so to complete the square, if you remember how to complete the square, the first thing you want to do is try to get rid of these terms here, your leading coefficients for your quadratic terms. And so when I do that, I'm going to have 9x squared plus 8x. I'm going to leave my blank, and I'm going to close my parenthesis, plus 16, I'm going to take out the 16, y squared, plus 6y blank equals negative 144. Okay, I did that so that the coefficient of my x squared and my y squared is now 1 instead of 16 and 9. Now that I do that, what I do is I take my linear term, I divide it by 2, and that gives me 4. Now what I do is I then move that up here and square it. Okay, now if I add 4 squared to here, this becomes 4 squared, it's always going to be positive, whatever's there. Then I have to also do the same thing to the other side. But notice it's being multiplied by that 9 that's out front. So what I really have is 9 times 16 added to this. So I also have to add plus 9 times 16 out here to this, to the other side of the equation in order to keep it equal. All right, now I'll do the same thing to the other. 6 divided by 2 is going to give me 3. And then I move that up here and square it. It's always going to be positive because it's squared. So it's like I'm adding 9 here, but that 9 is being multiplied by 16. So now I am also adding another 9 times 16 to this side. Okay, so now that it's there, I have it in the form I need to complete my square. So I've got 9, parenthesis, x. It's going to be, complete the squares, it's going to be x plus 4 squared. And that 4 goes there. And this sign always comes from here. Plus 16, y plus 3. Again, that sign, whatever that sign is, goes here. And this 3 goes here. Is equal to, and now I simplify all of that, negative 144 plus 9 times 16 plus 9 times 16, and it gives me 144. And now that I'm here, I'm almost finished. We know for the standard form what we want to do is have it equal to 1, so I'm going to divide everything by 144. And once I do that, I end up with x plus 4 squared over 16 plus y plus 3 squared over 9 equals 1. And then I can rewrite that if I want to as x plus 4 squared over 4 squared plus y plus 3 squared over 3 squared equals 1. All right, and now you can see it's pretty clear that I do have an ellipse. And for my ellipse, I can go ahead and graph that. What I would have is, let's say I wanted to find the center. Let's take a little more space for that. The center would normally be at 0, 0. But because I am going to go left 4 and then down 3 because of my HK, then that center is going to become negative 4, negative 3. All right, and then we've got our vertices. Now the initial vertices, for this, you notice that the 4 is under the x, so that's your larger. So your initial vertices are going to be at 4, 0, and negative 4, 0. But now we're going to go left 4, so I subtract 4 from the x, and I subtract 3, and then I subtract 4, and subtract 3. And that gives me my vertices. And then if I wanted to label the foci, let's say I did want to label the foci on this one, or actually let's do endpoints of the minor. So initially the endpoints on the minor axis are going to be at 0, 3, and 0, negative 3. But then I need to change those over to, I'm going to subtract 4, and then I'm going to subtract 3. Get that. And then let's say I did want to find a foci here. Then we need to do a little work with a triangle. And so with our triangle, what we know, since we have an ellipse here, is that that major axis is going to be 4. And this is 3. And then so our initial foci is going to be, if we solve this, we end up with f is equal to the square root of 7. Okay, so the original is going to be at root 7, 0, and negative root 7, 0. So then when we do our transformation here, we're going to again subtract 4. So we've got root 7 minus 4, and then negative root 7 minus 4. And then we're going to subtract 3, so that's going to become negative 3, and that's going to become negative 3. And then we have all the points, and from there you would just need to graph it, or sketch a graph like we did in the last example. All right, and here's our third example. On this third example, we're going to find the equation of an ellipse with the center at negative 6, 5. The endpoints of its major and minor axes are given, and we're going to find the coordinates of the foci. Okay, so what we know is we have a center, and let's just label it at the point negative 6, 5. All right, endpoints of the major and minor axis. It doesn't tell which is which, but we should be able to figure this out. Okay, so we've got negative 6, 5. So you notice that those have coordinates of 5 on it. So if that's this is at negative 6, 5, then negative 9, 5 is going to be here. And then negative 3, 5 is going to be somewhere over here. Okay, and if we look at those distances, from negative 9 over to negative 6, this distance right here is going to be 3. Okay, and then from negative 6 to negative 3, this distance is also going to be 3. Okay, and then we have, so we've taken care of those two. Now we've got negative 6, 7. So this time we're moving vertically from that center. So negative 6, 7. Graph paper might actually make this one easier. So from negative 6, 5 to, so we're going from 5 to 7, and that's 2. So now it's pretty clear which one's the major and which one's the minor axis. And let's go ahead and get the negative 6, 3. Again, that's 2. So our ellipse is going to look something like this. Okay? And we need the equation of this ellipse. All right? So since we have the negative 6, 5 as our center, we should be able to go ahead and set up the main part of that. So we've got x minus the negative 6 is going to give me plus 6. squared plus y minus the 5 squared over something squared, and something squared is going to be equal to 1. Okay, so we have that, and on the major axis, which is our x, is going to be along the x, or along the equation y equals 5. We're going to get that this is 3 here, so that's 3, so this is going to be our 3 squared, and then we get this is 2, so this is our 2 squared. And the other thing it asks for is our foci. Okay, so what we need to do is sketch our triangle. And on our triangle, we have, this would be 3, the hypotenuse. This is going to be our foci, and this is 2. Remember where the foci is located on this. The hypotenuse is always going to be the distance between your center and endpoint on your major axis when you have an ellipse. So the foci squared is going to be 3 squared minus 2 squared, 5, and f is going to be the square root of 5. So we get the square root of 5 there. Now that's the length. So what we have to do, that means that focus is root 5 from that center. So the center is -6. The focus is going to move along the x, so it's going to be plus root 5, and then -6 minus root 5. And that's it for that example. Let's move on to example 4. This time we're going to identify and sketch the graph of y equals 3x squared minus 12x plus 10, and we're going to label the characteristics of the conic. This one, it should be pretty obvious that what we have is a parabola, and that's because we only have one quadratic term, being my x squared. So what I'm going to do is, first of all, try to get this in and complete the square. So I'm going to move my 10 over. I'm going to factor that 3 out and leave space here. And so when I take half of this, and that gives me 2, and I square it, it goes here. So essentially what I'm doing is, that's positive, that's 4, and it's being multiplied by 3, so I'm really adding 12 to that side, so I have to add 12 to this side here as well. Okay, so now I have y plus 2 is equal to 3 times x. Remember, the sign comes from here, minus, this goes here, 2 squared. Okay. So now what we're going to do is see if we can find the correct characteristics of this one. And sketch the graph. So actually, if we just go through and label the characteristics, then that should be fine. If we recognize that y plus 2 as one set, and the 3 is going to be our 4p. Okay. That 3 is going to be our 4p. So that p is going to be equal to 3/4. Actually, I wrote that wrong. Let's back up a little bit. We might want to, we probably want to, what we want to do is look at that. We could do that as 1/4p. I messed up here. Okay, what we want to do is isolate the squared term. Always remember to isolate the squared term, which is what I forgot. So if I do, I'm going to divide both sides by 3, which is going to leave me with 1/3 y plus 2 equals x minus 2 quantity squared. All right, so the easiest thing is to find your, is going to be to find your vertex. And your vertex is going to be at 2, -2. All right, and then is going to have a focus. So from there, so there are two things you could do. If you remember it from there, you can do it without the transformation. But if you don't remember it from there, just think about this here and do your movement from there. And then you can say here you've got 0, 0 is going to be your vertex, and then from that vertex you're going to move right 2, which changes this to positive 2, and then that plus 2 is going to move you down 2, and that's how you get your negative 2. Okay. And then the next thing you want to do is figure out what your p-value is. So if you're figuring out your p-value, you're going to say 4p is equal to 1/3, not the 3 that I had initially, and that's because you want to isolate your quadratic term when you're dealing with the parabolas. That's going to give us that p is equal to 1/12. Okay, and then so when you find your focus on this one, because it's an x squared, we're either going to open up or down on the x squared. So the 1/12 is going to get added to the y coordinate here. All right, so you're going to have a focus, and because it's positive, our focus is going to be 2 and then negative 2 plus the 1/12. And you could go ahead and simplify that. And then for your directrix, you're going to have it's going to be the equation. And remember, it's going to be a horizontal line. So when it's a horizontal line, we've got y equals. And you're going to have your negative 2 minus 1/12. Okay. And that's going to simplify to y equals negative 25 over 12. Okay. So there you have your focus, your directrix, and your vertex. And remember, if you didn't want to do it from here, you could always start going from the one where the center's at, or the vertex is at 0, 0, and make your transformation from that one. All right, and we have one last problem here. We're going to graph the equation. I'm going to do this from the transformation, as I mentioned in the last slide, and we're going to graph this. So looking at it right now, I can go ahead and tell that what we have is an ellipse. So let's compare it to x squared over 3 squared plus y squared over root 3 squared. Now, if that's the case, then I'm going to make myself a little chart here, as I've done earlier, where I'm finding my center. I'm finding the foci. And then what would be my x-intercepts is going to be, you're going to have vertices, and you're going to have endpoints of your minor. These were x and y. These, you could also say x-intercepts and y-intercepts if you're talking about the center being at the origin. All right, so for this one, let's see about x and our y. Our center is going to be at the origin. Our foci are going to be, we would have to use a triangle to figure that out. So what we have is 3. That's going to be 3 because the major axis is on our x, and that's 3 units from the center. This would be root 3, and we're trying to find how far the focus is from the center. So our focus squared is equal to 3 squared minus root 3 squared, and that means our focus is going to be the square root of 9 minus 3, and the focus is equal to the square root of 6. All right, so it's on our x again, so we've got plus root 6 and negative root 6, 0, 0. Our vertices are going to be like what our x-intercepts would be. So if you go, you notice that that's going to be 3, 0, negative 3, 0. And our endpoints of our minor are going to be at 0 root 3, and 0 negative root 3. And now we just need to make the transformations for each of those. So for each of my x's, I'm going to go and I'm going to do this. This is going to tell me to add 2 to each of my x's. So when I add 2 to each of my x's, I get 2, 2 plus root 6, 2 minus root 6, 5, negative 1, 2, and 2. Okay, and now for my y's, what I'm going to do is subtract 3. So that gives me negative 3, negative 3, negative 3, negative 3, negative 3, root 3 minus 3, and negative root 3 minus 3. Okay, and so now I can use all of that information to either sketch a graph and label the points or actually plot them on the coordinate plane. And that is the last example I have for this section.